Hey, this is Joel Duff. Welcome back to my channel. And today I've got answering student questions. Actually, just one question this time. This is an excerpt of what became a 5.5-hour video that I made for my students this summer. Right? They asked in a discussion forum a series of 25 questions, 25 students, 25 questions, and I decided I would do a video response to them. In my class, when I'm doing face-to-face, they ask anonymous questions, and I have to stand in front of the class and give somewhere between a 2 and a 5-minute response. Now, I'm not limited to the 5 minutes since I was on video, and obviously I wasn't limited because I went for hours and hours and hours. Some students got an entire lecture in response. So I've taken a couple of those questions, and I've made small videos out of those. And then eventually I'll publish the entire video. But I just want to remind you, as you listen to my responses, these are mostly on the fly. I mean, I didn't do a lot of preparation to answer these questions. I simply looked at it and said, here's how I would respond to that. Here's some thoughts of mine. And those thoughts also are in the context of this is a class that has a broad spectrum of students in it from a wide variety of different backgrounds and different opinions about mostly the topic of evolutionary biology. And so my responses have that in mind. Some of my responses are a little different than maybe the tact I would take if I were sitting down with you over a cup of coffee and talking about these subjects, or if I was talking to a specific critic or something like that. So just bear that in mind in terms of the style of response that I'm going to provide for some of these questions. I'm also in a sort of a teaching mode because I'm trying to use my responses to help them understand some principles. So I'm breaking down some of their questions into fundamental assumptions and trying to derive sort of like things that I know that they're going to need to know, through the rest of the class, and trying to sort of squeeze those elements into my answers to their questions. Okay, so with that caveat, or those caveats, let's proceed to answering a student question. Coming on up. All right. This is a really big question, and it's with some trepidation that I'm going to begin to attempt to answer some of these questions. And I'm gonna take a kind of a simple approach to this very first question because we're going to have 2 or 3 other questions that are going to be very similar to this one. So I will provide different slices, if you will, of reactions to these questions at different times, rather than trying to do it all at once right here. If you know any of my other work outside of class, then you know that I write and talk a lot about sort of what we call the integration of science and faith. So I do have a special interest in this area and have a lot of thoughts on it. But just sticking to this idea of like, how would you, here you're in a school or situation, or you have a background where maybe you've never learned anything about evolutionary biology because maybe that particular topic has been avoided. And it's probably been avoided because there's the perception that, and I don't want to say perception, the reality is that for many folks, their interpretation of the history of the universe and of life, they feel like evolutionary theory provides a contrary explanation that is outside of their beliefs. And therefore, they feel like they are in conflict and don't really want to experience that conflict, right? And so the best way to not experience that conflict is to simply avoid the conflict by not talking about it. And this is the route that many people in K-12 education go, is simply just like, well, let's just avoid the topic of evolutionary biology. One of the things I'd say about that, and you would know that taking this class, is that you've probably realized by this point that evolutionary biology, and when you take that textbook, and you're like, what am I learning from this textbook? And you go through it. The controversial parts of evolutionary biology in the largest sense that we're talking about consist of a very small segment of that book, right? Because what are we spending most of our time on? We're spending an enormous amount of time talking about natural selection as a process, like the population genetics of that. How do allele frequencies change over time? What influences are there in populations and on populations, both by other organisms and by the about abiotic forces in the environment? How are they affecting how populations are changing and adapting in this present world? right? We're talking a lot about that. And then we explore the idea of speciation, about how populations are becoming fragmented and becoming more different from each other under different environmental conditions. Right? And we're talking about genetic drift, and we're talking about mutations. We're talking about processes that we can observe, processes that we test, processes that we can model. And then we're talking about observations from the fossil record to look at how organisms have changed and persisted and gone extinct in the past. And the vast majority of all of that is not at all controversial, and in fact is very helpful for understanding the balance of life on Earth. Why do we have the types of diverse organisms that we have? How do they all coexist? Why do organisms have certain features? And then we are in evolutionary biology trying to go to the next step and say, how did they get those features? How do plants have spines? What are the forces that enable organisms to develop characteristics to adapt to the challenges in their environment? And so we talk about genomes, and we talk about sexual selection, and we talk about a bunch of different factors that are involved in those things. We talk about viruses and how they're evolving to the organisms that they're inhabiting, and how we are adapting to the viruses in our habitat, and how bacteria are developing antibacterial resistance and so forth, right? We spend an enormous amount of time on what I would call very practical aspects of what you can learn from evolutionary biology that helps you understand today's world. All right, so that's a long-winded way of saying that if you avoid that topic, evolutionary biology, and often everything, the baby is thrown out with the bathwater, right? When you say, well, we're not going to talk about evolution. And so you don't even talk about natural selection. You don't talk about speciation. You don't talk about these things at all. Well, then you really are missing a large portion of biology. There's this phrase, nothing makes sense in biology except in the light of evolution. People hear that phrase and they think, well, that means I have to accept universal common ancestry of non-life becoming life and then becoming all different types of organisms. That to me is what evolution is. But really that phrase is saying it's hard to understand why this organism, this species over here has this characteristic living in this environment, whereas over here in this other environment you have another species and has slightly different characteristics. Why are those two things different? Why is this one color and this one's a different color? But evolutionary biology provides a robust scientific explanation, all right, for those types of differences. And hundreds of thousands of other features of organisms on the Earth today can be understood within the light of evolutionary biology. And so I guess the first thing I'm saying is you're missing a lot if you just decide you're going to throw everything out and you don't want to talk about anything that smacks of evolution. So then when it comes to the question of, well, how would you teach evolution? Well, rather than teaching it in a adversarial sense, I think of it as just like I'm thinking of it in terms of this class. No matter what your perception or beliefs are about the origins of life, about the place of man in the universe, about the history of the Earth in terms of its age or whatever, you should know what the scientific consensus is on explanations for living things and their diversity. What is the source of diversity in the world? And the most robust, best accepted explanation, naturalistic explanation for the diversity of living things is evolutionary biology. Right? I can't tell you any other theory that has been proposed based on natural mechanisms, scientific principles that better explains why we have the different types of animals and organisms that we do, right? You learned a little bit about Lamarck. We just saw something about Buffon. Buffon had an idea about the origin of living things. That's a terrible idea. I mean, there's really no scientific evidence for that. Lamarck had an idea, and it was popular for a time, but we've learned a whole lot, and it's fallen out of favor very quickly after Darwin came along, because Darwin had a just much better explanatory framework that takes account for a large amount of the evidence of the observations we make of this world. So, point number one is, I think it's just important that you know what evolutionary biology is, and you understand the mechanisms of evolution. And at the end of the day, as I say, you can look at that and say, like, okay, I get what natural selection is, and here's what it can do. Maybe I haven't convinced you, or you're not convinced by what you've learned from your textbook that about how complex traits, like the origin of venom. And you're like, I just don't think that natural processes can make venom, despite whatever evidence that has been presented. And you choose to believe that there's something else involved in the origin of venom. Well, if you're going to add another explanation, and that explanation is a supernatural explanation, right? That God created an organism or they created organisms and then created the capacity for making venom in a certain organism. Then that's up to you to make that decision that there is another form of evidence. There's another explanation that you are more convicted by, right? But you should acknowledge that that decision you've made is not based on scientific evidence. But if you feel like scientific evidence isn't all that there is in this world, and I would agree, scientific evidence isn't everything. It can't explain everything about the world, right? There's lots of why questions that it has difficulty approaching. Or let's put it this way, it can't address, scientific theories can't address questions of supernatural origins. Because if something is supernatural, it's outside the bounds of us being able to investigate it. So I would put it in the context of, this is a scientific theory. All right, so evolution is a scientific theory. So in biology, you would emphasize that evolution has, here's the evidence for this particular theory. A theory is a well-grounded hypothesis. A hypothesis has been tested and found to be consistent with lots of evidence, right? And so multiple different disciplines in biology have converged to provide evidence that suggests that organisms adapt and change in the environment. And that as they adapt and change over long periods of time, that they can change from one species to another species over time, that speciation happens. And so this is the scientific explanation that explains the natural phenomena or the natural observations we make. Religion provides another framework for potentially understanding the origin of life. But I would say it more provides an explanation for the meaning or purpose of life. Right? I can't really say a whole lot about what the purpose of a particular organism is in terms of, I can say what the purpose of a particular feature of an organism is within a naturalistic framework. But what's your purpose for being here? I don't really have any way of addressing that from the scientific perspective. Right? So in terms of teaching it and teaching alongside of, or teaching it without interfering with religion, it doesn't interfere with religion if you present it as, this is what you should know that science thinks. Like, this is the current consensus. Maybe 200 years from now, there'll be a shift in our understanding of scientists' understanding. But currently, right now, this is the agreed upon best explanation to explain the observations that we've made of this world from the fossil record, from genetics, from morphological observations, from behavior, lots of different fields. All right, so with that, then you simply encourage the things you should be encouraging in the educational process, right? Critical thinking, right? Encourage people to explore different perspectives, understand what scientists are saying, what is the evidence they're using to support these different things. examine that evidence for yourself and decide, is that a consistent explanation? And you might come to the conclusion that, you know what, there's a lot of evidence for human evolution, or a lot of evidence that, yes, there were, whales have so many features that are like land animals, that it's not an inconsistent hypothesis, or it's not an improbable hypothesis that at one time they shared a common ancestor. At the end of the day, you still may decide that I weigh things, right? Here's my scientific evidence, and maybe I have my scriptural evidence, right? I have Genesis 1-4, and I believe it should be interpreted in a particular way. I have a particular interpretation of that I think is the most faithful interpretation. By the way, that also includes hermeneutics, which is methods of interpretation and so forth. So there's a whole kind of science to interpretation and understanding literature. But within your understanding of that, you may decide that whales are a separate creation. And that is another piece of evidence for you to consider in this world. And you might decide, at least you would understand what evolutionists are saying. And you would at least understand, here's the evidence that they're providing, and you could have a rational conversation with somebody, say, I get that. That evidence does look compelling. I've chosen not to believe that because I place this evidence over that evidence. And here's the reason why I'm not going to believe, that aspect of evolutionary biology. But here's the thing. You could still agree that, dolphins are evolving, right? That they are adapting to their environment. And you could say that over the last 4,000 years, they've changed quite a bit. In fact, that's what we've seen, that's what creationists do. So-called creationists that deny evolution, except that they believe that, 2 dogs became 35 different species of dogs. So they believe in lots of speciation. They believe in natural selection. They believe in genetic drift. They believe in the processes that we're learning, although they have different takes on them in terms of the speed and rate. And so you have the ability to assess that kind of hypothesis, because their hypothesis is a kind of naturalistic hypothesis about the origin of different species of dogs. But they would say dogs and cats have separate origins, like they were supernaturally created separately. But after that, they evolved through natural processes. So that's already a combination of naturalism, of explaining, well, I guess put into a theistic form of language. That would be saying that God is using secondary processes, like he's using the mechanisms of the world that he created to allow for speciation to happen. But he didn't create those types of mechanisms, couldn't have created dogs and cats from a common ancestor. Or maybe you'll look at it and you'll say, I think they could have come from a common ancestor, but I believe that they didn't. Right? It's possible, but I don't believe they did. All right, I'm giving you lots of different, I'm spilling over lots of stuff here, but the idea is in class, if you can present at least, here's what the facts of what evolutionary biologists believe, and here is their evidence. Here's what you should know about it. You should at least know what they believe and what it is, because that way you won't fall prey to a bunch of misconceptions, which is this is what happens with a lot of people. There are a lot of creationists that use your misconceptions about what evolution is to sound convincing. And so you really should only be convinced by things that are true representations of your opponent. And the only way to know what evolutionary biologists say is to take a course like this to understand something about the basics of evolutionary biology. Now, I would also say that there's a ton of compatibility. Right? There's a ton of compatibility of our textbook. You're going to find that if you read 800 pages of this textbook, that you're probably going to, even if you come into a class and think I don't believe in evolution, I don't believe in this evolution thing, you're going to find out that you're going to agree with 90% of the book, because you're going to realize that 90% of the book is about things that are just about how the world operates right now, in the here and now, and are processes that clearly are going on that can be tested. And there's abundant evidence, right? This is what organisms do and how they change and how they interact with each other. And so there is a large amount of compatibility between evolutionary theory and most every type of other belief about the origins and of life and diversification of life on Earth. I guess lastly I would say, out of all the things I'm forgetting to say, but I'll say this. This discussion forum is one very, very small way to have this kind of discussion, right? To be able to at least feel out, hey, different students have different ideas about things. They have different concerns. They have different perceptions of what evolutionary biology is. And they have different misconceptions about even what religion might say. So there are students who don't know anything about some religious ideas, or even the conflicts that they might have with evolutionary biology. Maybe they're just fully accepting of evolutionary biology. They should be aware of why it is that when they just say, well, evolution is true, some people have very strong reactions to that. Why do they have those reactions? And so all of this is just to allow us to see is to experience the dialogue and differences among us. And to find out can we agree? Where do we agree? And I think that what you'll find is we agree on a lot once you boil it down, once you distill it down. Okay, we have to move on. I've got to move on to the next question. This is kind of a frustrating experience for me. I'm not real happy with my answers to this point. And if you might be wondering, like, well, usually I do this live. Like, how do I feel when I'm getting these questions? Like, I've not been able to look at it before. I'm just asked right in front of class, and I have to answer them. Amazingly, being spontaneous in front of a class and then like having a whiteboard and like drawing stuff is so much easier than sitting here and talking to a screen and trying to answer these questions. I find myself just not really getting into a groove.